What we are starting with in this lecture is about the nomenclature of alcohols and phenols. So we will see here how to write some of the common and IUPAC names for alcohols and phenols. Just to remind, because this is a topic that you already have done in class 11th, for alcohols, the suffix to be used at the end, okay, as you know, suffixes used at the end is ol, it's ol. Prefix, if you have to use, is hydroxy. Prefix is used before the word root, pre, and suffix is used after the word root. And one more thing I'll tell you, that the common names of alcohols are written as alkyl alcohols. The common names are simply written as alkyl alcohol. So you write the name of the alkyl group that you see there and you add alcohol to it. For example, I'll give you a few examples of common names. For example, CH3OH. Now, which alkyl group do you identify here? The alkyl group that you identify here is methyl. Okay, so methyl, and that's it. Identify the alkyl group methyl and put alcohol behind that. So methyl alcohol. Let's say you have this alcohol CH3CH2OH. Now which group do you identify here? Ethyl group. So this is termed as ethyl alcohol in the common system, certainly. Let's take another example, CH3CHCH3OH. Now if you are able to identify the alkyl group here, CH3CHCH3, this grouping of 3 carbon atoms, what is this called? Isopropyl. So this becomes isopropyl alcohol. These are all common names that you are looking at right now. Then one alcohol, quite a common alcohol, CH2OH, CH2OH, and the common name of this compound is glycol. It's a trivial name, common name, glycol. Then there is another very important alcohol. The formula is CH2OH, CHOH, CH2OH, and this is called glycerol. So these were few examples of alcohols and their common names. But in general, alcohols are in common system named as alkyl alcohols. Okay. Now we are moving on to writing the IUPAC names. So common names we have seen, and though they are important, but what is more important for us is to know the IUPAC system of nomenclature. How do we write the names of these alcohols in the IUPAC system? So let's take the example of the first alcohol that you just saw, which was methyl alcohol. Now in the IUPAC system, the carbon chain is of only one carbon atom, and so the word root is what? Methane. In the word root methane, you will drop the E and you will substitute it by the suffix. As I told you, the suffix is all. So this compound with the word root methane, E being dropped and substituted by the suffix which is all, becomes methanol. One carbon atom, so it's a derivative of methane. Drop E and put the suffix also, methanol. Let's say I take this example. Now here, if you number the longest carbon chain, it contains 2 carbon atoms, so the word root is ethane. Drop the E and put the suffix, so this becomes ethanol. Now let's take another example. Suppose I have this compound. Again, the rule is select the longest carbon chain. The longest carbon chain is of 3 carbon atoms, 1, 2 and 3. Now if you number it this way, 1, 2, 3, the hydroxyl group is on the second carbon atom. Now with 3 carbon atoms, the word root is propane. So you have to drop the E, so it's propane, and now specify the position of the functional group, which is second. So this is propan 2 all. When the position of the functional group is 1, like in this case and in this case, then you need not specify. But if it is not 1 but any other, then you have to specify. So this compound is propan 2 all. Let's take more examples. Suppose I have this compound CH3CHOH, CH2, CH3. Now you can easily see that the longest carbon chain here is of 4 carbon atoms, 1, 2, 3, 4. Now whether to number it from left or right, you will decide on the basis the functional group comes at the earliest from which side. The functional group, if I start from the right side, will be on which position? Third. But from the left side, it is on which position? Second. So we prefer numbering it from the left side so that lowest possible numbering can be given to the functional group. Now the word root with 4 carbon atoms is butane. So you replace the E of butane by the suffix -ol, and what is the position second? So this is butane 2-ol. So this alcohol is termed as butane 2-ol. Let's take another example. Okay. Now identify the longest carbon chain. And the longest carbon chain must contain the functional group. So the longest carbon chain is of 3 carbon atoms here. It's 1, 2, 3. You can even take this 1, 2, 3. It remains the same. Even the position of the functional group remains the same in both the cases. It is always at the second position. So let's consider this as the longest carbon chain here. Carbon number 1, this is 2, and this is 3. So the functional group is on second position, and you have something else also on the second position here. What is that? The methyl group. So first of all, you will have to write the methyl group, the prefix, the substituent, which is on second position. So it's 2-methyl. Okay, 2-methyl. And now our word root as per the longest chain is propane. So propane, and you drop the E, and on the second position you will put the suffix -ol. So this is 2-methyl propane 2-ol. Okay, let's take another example. CH2OH, CH2OH. If you remember, in the common system, this alcohol is glycol. Now when you name glycol, you number the longest carbon chain, which contains 2 carbon atoms. So the word root is ethane. Now I have been dropping the E in the previous cases, right? But see, first of all, see the name, then I'll explain. I'm not dropping the E this time. It's ethane, the 2 carbon atoms. I'm taking the word root ethane, and then 1 and 2. So 1, 2 diol. There are 2 hydroxyl groups here. So I'll have to use the prefix diol. And that is the reason why the E is not being dropped here, because immediately after E, what do you have is D. Let me tell you the rule, though you should have learned this in class 11, but I'm again reminding. What is the rule? When the word root alkane is followed by E, I, O, U or Y. Okay, when the alkane, the word root is immediately followed by what? A, E, I, O, U or Y, then this E has to be dropped. Okay, then the E has to be dropped, otherwise it's not required. So look at this case. Now this word root's E was followed by D. There is no vowel here, A, E, I, O, U or Y, but it's followed by D, and therefore it is not to be dropped. So the name of this compound is ethane 1, 2 diol. Now I'm taking another similar example that we have seen. CH2, CHOH, another CH2OH. Now in this alcohol, the longest carbon chain is of 3 carbon atoms, right? So the word root has to be propane, right? Now you need to consider, should you drop E or not? What is the ground? When you will write the positions, you will be writing 1, 2, 3 triol, because there are 3 hydroxyl functional groups, so triol. And I have not dropped the E. I have retained it because I knew that this E is going to be followed by T, which is not a vowel, neither it's Y. Remember the rule, if the E is followed immediately by A, E, I, O, U, Y or A, E, I, O, U or Y, then it is to be dropped. But in this case, this E is not to be dropped. So the name is propane 1, 2, 3 triol. Let's consider a few more examples, and probably now cyclic alcohols, like this example. Now this is a cyclic compound, and this is cyclohexane. Certainly I will consider the functional group on the first position. So what is the name? It's cyclohexane. hexane 1 all, or you can simply write it as cyclohexanol. As I told you that when the position of the functional group is first, then you may even skip writing the position. So it's cyclohexanol. Let's consider one more example of a cyclic alcohol. Now in this alcohol, you have another group substituted here. It's a methyl group, right? Now when you start numbering, you have to start from the functional group. The functional group always gets the higher priority. So this is 1 and then you come clockwise. So this is 2. So it's 2-methyl, and now this is cyclopentane. So 2-methyl cyclopentanol. The suffix for OH group is always also 2-methyl cyclopentanol is the name. Let's take another example. The compound is CH3CHCl, CH3, again CH3, CH2OH. Now we have to identify the longest carbon chain. Certainly the longest carbon chain here is this one, 1, 2, 3, 4, 5. You will number from the functional group. So 1, 2, 3, 4 and 5. On the 4th position you have a Cl. On 2nd and 3rd position you have methyl. This is chloro and these are methyls. So the names of the prefixes to be written alphabetically. Now what comes first alphabetically is C, chloro. Therefore we will write C first. So 4th position we have a chloro. So 4-chloro, and then 2nd and 3rd position. So 2, 3, and there are 2 methyls. So 2, 3 dimethyl, and then with 5 carbon atoms it should be pentan 1 all, or simply pentanol. So 4-chloro, 2,3 dimethyl, pentan 1 all, or pentanol. Let's take one more example, which is CH3, CH2, CH, CH2Cl, another CH, CH2OH, CH, CH3, CH3. Now here you have to look for the longest carbon chain that must contain the functional group. Let me explain this example to you. If I consider this chain 1, 2, 3, 4, 5, 6, this contains how many carbon atoms? 6. But if I consider it this way, 1, 2, 3, 4 and 5, this contains only 5. So should I go for 6 as the longest chain or 5 as the longest chain? I will have to go with 5 as the longest chain. You know why? Because the rule is select the longest chain containing the functional group. Now this chain does not contain the functional group, so I can't take this. Otherwise, this is a chain of 5 carbon atoms containing the functional group. So I will take this and number it from the functional group. So 1, 2, 3, 4 and 5. This is the longest carbon chain. Now on this longest carbon chain, one substituent that I have is this. This is chloromethyl. With 1 carbon you will call it as chloromethyl. The second substituent that I have here is a bulky substituent. Now such bulky substituents can be named further as, you start with the carbon with which this group is attached to the main chain. So this is the carbon and number it. So 1 and 2. On first position, this first position you have a methyl. I am writing the name of this group here on the side. This group is termed as 1-methyl ethyl. Okay, what is this group? It's 1-methyl and 2 carbon, therefore ethyl. So 1-methyl ethyl. And what was this? This group is chloromethyl. Now see which one comes first alphabetically? Chloromethyl. So we will now list them alphabetically. So on the 3rd position, we will first write chloromethyl. So 3-chloromethyl. And then on the 2nd position, within brackets, the name of this bulky group will be written. It is 1-methyl ethyl. And now the longest carbon chain was of 5 carbon atoms. So pentan, and the group is on the first position. So pentan 1 all, or simply pentanol can be written. Now we will consider some phenols, and let's see how to write their IUPAC names, and we'll learn some common names also. Benzene with OH is called phenol, and this is also called benzene 1-ol. What I've done is I have dropped the E from benzene and I've replaced it by the suffix which is -ol. So it's benzenol or benzene 1-ol. Benzene with one OH and one CH3. You have to learn it like this only, that benzene when contains one OH and one methyl group, then this compound is termed as cresol. But if you can identify the positioning of these two functional groups, when the functional groups are placed 1, 2 next to each other, then this is called as ortho positioning. So this compound is orthocresol. And if you have to write the IUPAC name now, orthocresol is common. What will be the IUPAC name? It will be 2-methyl phenol. Benzene with OH on the first position, you know already that this compound is phenol. So second position you have methyl, so this is 2-methyl phenol. Now likewise, if I take this OH and shift the position of the methyl group to this is still cresol, but now the positioning is 1, 3, which is known as meta. So this compound in the common system is metacresol, and IUPAC name is going to be 3-methyl phenol. So in the IUPAC system, this is 3-methyl phenol. And exactly same manner, we can have a third isomer of the same compound when I shift the position of methyl to this, which is 1, now 4 positioning. And this is called paracresol, and the IUPAC name being 4-methyl phenol. So this is how these compounds are named in the common system and in the IUPAC system. A few more phenols which you have to learn, by the common names also are benzene when contains two OH hydroxyl functional groups next to each other, 1, 2 positioning. No ortho here, but this compound is known as catechol. The common name of this compound is catechol, and if you want to write the IUPAC name, then yes, it is benzene 1, 2 diol, because in the first and the second position you have two OH groups, so benzene 1, 2 diol. Likewise, if on the benzene ring you have two OH functional groups, and what is the positioning here? 1, 3, then this compound in the common system is called resorcinol. And the IUPAC name of resorcinol, you can probably think of it now. It will be benzene 1, 3 diol. And one more isomer of this compound is when the two OH groups are present like this at 1, 4 positioning. In the common system, this compound is known as hydroquinone. It's called hydroquinone or simply quinol. Hydroquinone or quinol, and the IUPAC name of this compound is benzene 1, 4 diol. One more phenol we will write the name for, and it's a substituted phenol with 2 methyl groups. Now certainly the numbering has to be done from here. And now whether you move clockwise or anti-clockwise, the methyl group is going to get second number from both the directions. So let's say 2, 3, 4, 5 and 6. So on the second and the sixth position you have these methyls. So list that first. So 2, 6 dimethyl, 2, 6 dimethyl and phenol. Benzene with OH on the first position is phenol. So 2, 6 dimethyl phenol. And just make a correction that D has to be capital. When you start the name, the first alphabet that you write is capital. So 2, 6 dimethyl phenol. And now I am moving on to the nomenclature of ethers. We have seen it for alcohols and phenols, and now we are going to look at the nomenclature of ethers. Okay. In the common system of nomenclature, when you write the names of the ethers, I'll take an example and explain. Let's say I take this ether, CH3O, CH3. Now what you do in the common system is just identify the two alkyl groups. Like the alkyl groups here are methyl, and there are two. So this is simply dimethyl ether. So this compound in the common system is called dimethyl ether. Now let's say I take this ether, CH3CH2, CH2, CH3. Again identify the two alkyl groups. So it's again what? Ethyl groups, and there are two such groups. So it's diethyl ether. Let's take another example where I take these two different alkyl groups. Now on the left side you have methyl, on the right side you have ethyl. So again you have to write the names of these two alkyl groups but alphabetically now. So ethyl comes first alphabetically, therefore I write ethyl first, then comes methyl, and again what? Ether. So this is called ethyl methyl ether. I'll just give one more example for the common system. Let's say I have this compound CH3O C6H5. Now identify the alkyl groups. This is methyl, and I told you in the last class what is C6H5? It's phenyl. So which one comes first alphabetically? This is M and this is P, methyl phenyl. So M comes first, so we will first write the methyl group, methyl, and then phenyl ether. So this is quite simple. You just have to identify the two alkyl groups and list them alphabetically and end the name with ether. Now we will be moving on to the IUPAC system of nomenclature for the ethers. And let me take example and explain it to you. So I'll take the simplest example to begin with, CH3OCH3. Now one thing that you should note down here is that the prefix which is used for ethers is alkoxy. Prefix means before the word root. Okay, the prefix used for ethers is alkoxy. Now because the two groups are the same, so it won't really make a difference. The rule is that one of the alkyl group is to be taken with oxygen. One of the alkyl group is to be taken with oxygen, and this will be regarded as the alkoxy group, and the remaining part will be the alkane part. Okay, one of the group is to be taken with oxygen as what? Alkoxy, which will be the prefix, and then the name will then end with the alkane. So in this case, what is this alkoxy group? With one carbon atom, you know, it's methyl group, so this becomes methoxy. So this is methoxy, and one carbon alkane is what? Methane. So the IUPAC name of this ether is methoxy methane. One alkyl is to be taken with oxygen as alkoxy, and the other alkyl will be taken as the alkane, the parent alkane rather. Let's take another example. Suppose I take CH3CH2O CH2 CH3. If you remember, we've written the common name. This was diethyl ether. Again, the two groups are same here. Now, when the two groups are same, you can take any one of the two groups with the with oxygen as alkoxy. Now, ethyl group with oxygen becomes what alkoxy group? It becomes ethoxy. So this is ethoxy, and now with two carbon atoms, what is the alkane? Ethane. So the name of this compound is ethoxy ethane. Okay, and now let's take another example. Now I will change the alkyl groups on the two sides. So suppose I take this example to begin with, CH3O CH2 CH3. Now there are two different groups. Now how do I decide which one should be taken with oxygen as the alkoxy? So the rule here is the group with smaller number of carbon atom, the group with lesser number of carbon atoms is to be taken as alkoxy. Okay, the group with lesser number of carbon atoms is to be taken with oxygen as the alkoxy, and the one which contains a greater number of carbon atoms will be the parent alkane. So now what's the alkoxy group here with one carbon? It is methoxy. So this compound is methoxy, and what is the parent here with two carbon atoms? The alkane with two carbon atoms is ethane. So this compound is methoxy ethane. I hope you have been able to understand that which group is to be taken with oxygen as the alkoxy group. The one which contains lesser number of carbon atoms is to be taken as alkoxy, and the one with greater number of carbon atoms will be considered as the parent alkane. Okay, let's take now more examples of ethers, and the first example that I consider here now is now if you see this ether, again there are two different groups. left side contains 1 carbon, right side contains 3 carbon atoms. So if you can apply the rule, which one to be taken with oxygen? The one which contains lesser number of carbon atoms. And with 1 carbon, again, what is this group? This is methoxy. And now find out the alkane, the parent alkane. The remaining parent chain contains how many carbon atoms? 3. And so with 3 carbon atoms, the alkane is propane. So this compound is methoxypropane. Let's take another example. C6H5OCH3. Alright, and I'll just give you another structure of this compound. Actually, C6H5 is nothing but benzene with 1 hydrogen less. This is the C6H5 phenyl group, and to that we have this OCH3 group added. So it's the same thing, and you must learn the common name of this compound. It's a very important ether. This is called anisole. So C6H5OCH3 is anisole, but that's the common name. Now coming to the IUPAC name, as per the rule, which one should be taken with oxygen? This contains 1 carbon and this contains 6 carbon atoms. So certainly the one containing 1 carbon atom has to be taken here. So I take this with oxygen as the alkoxy group. Now only 1 carbon. So which alkoxy group will this be? Methoxy. Okay, so this will be methoxy. I can show it to you here also. So this I have taken with oxygen. This is methoxy. And now what's the alkane left here? The alkane left here is this or this, whichever you want to see. This is benzene. So this compound is called methoxybenzene. So methoxybenzene, and the common system is known as what? Anisole. Another example that we take is when we have benzene with O, CH2, CH3. First of all, benzene with OCH2 CH3 ethyl group is another ether known by a common name. This is called phenitol. And now when you write the IUPAC name of phenitol, certainly this is containing 6 carbon atoms and this contains only 2. So with only 2 carbon atoms, this you will take as the alkoxy. With 2 carbon, what is this? It is ethoxy. And again the parent which is left is benzene. So this compound is called ethoxybenzene. Consider another example. CH3O, CH, CH3, CH3. Okay, now I hope you can identify which one should be taken with oxygen. Left side we have only 1 carbon, right side we have 1, 2, 3. So this with only 1 carbon atom is taken here as the alkoxy group, and this is methoxy. Now to which carbon is methoxy attached? Center carbon. Now this is your alkane. This is your parent alkane. Here also you will have to number the longest carbon chain. So the the longest carbon chain, if you number here, is of 3 carbon atoms, and it will be numbered like this. And your alkoxy group is attached to which carbon atom now? Second. So you will have to specify the position now, that it's 2-methoxy. Okay, where is the methoxy group present now? On the second carbon. So it's 2-methoxy, and with 3 carbon atoms, the parent compound is propane. So it's 2-methoxypropane. Let's take another example. This is C6H5O CH2 whole 6 CH3. A very interesting example. See on the left side, there is a benzene ring, a phenyl group containing 6 carbon atoms. But on the right hand side, you have 6 plus 1, 7. So this is more. So this time, the benzene or the phenyl group with oxygen containing only 6 carbon atoms compared to 7 on the right hand side will have to be taken as the alkoxy group. And what's the prefix now? What is the prefix for this? I told you this group is known as the phenyl group. C6H5 is phenyl. Therefore, C6H5 with oxygen, this becomes phenoxy. So this is phenoxy. And how many carbon atoms are there in the parent chain? It's 6 plus 1, 7. So this is phenoxyheptane. The IUPAC name of this compound is phenoxyheptane. Okay, if you've understood this, let's quickly take 1 or 2 more examples. And this example is a very important example. C6H5O CH2 CH2 CH CH3 CH3. Now look at the compound. Left side we have 6 carbon atoms, and right side we have 1, 2, 3, 4 and 5. So this is 6 and this is 5. Though this group looks bulky, but it contains only 5 carbon atoms, and so as a rule this should be considered with oxygen as the alkoxy group. right? And this is the parent. Now what is this alkoxy group? It's looking so bulky. How do I identify its name? This is the functional group. So start numbering the chain from here. This is 1, 2, 3 and 4. Now on the third position you have a methyl. So this is 3 methyl. Okay, 3 methyl, and with 4 carbon atoms it should be butoxy. Remember, this is an alkoxy group. With oxygen the name always ends with alkoxy. Okay, you can't name it as alkyl or alkane. This is the alkoxy group. So number from here, this becomes 3 methyl with 4 carbon atoms, butoxy. So the name of this group is 3 methyl butoxy. And what's the parent here? What is C6H5? As a parent you will call it benzene, because you have actually replaced one of the hydrogen of benzene by this group. So it's a derivative of benzene. So 3 methyl butoxy benzene is the IUPAC name of this compound. One more example we'll take here, and that's CH3O CH2 CH2 OCH3. Now there are 2 ether groups here, okay, and this contains 1 carbon, even this contains 1 carbon, and this in the center is our parent chain containing 2 carbon atoms, right? So there are 2 methoxy groups and they're attached to which positions? First and second. So write the 2 alkoxy groups with their positions. So what will it be? 1, 2 dimethoxy, okay, 1, 2 dimethoxy, and with 2 carbon atoms, what is the alkane? The parent compound ethane. So 1, 2 dimethoxy ethane. 1, 2 dimethoxy ethane. One last example now, because I want to include a cyclic ether also with you people. So let's take this example. This is a cyclic compound containing a nitro group and ethoxy group. Now here you have to number this cycle. You can start from this or from this, but you will have to do it alphabetically. This is nitro, starts with N. This is OC2H5. What group will this be? This will be ethoxy. So starts with E. Therefore this has to be considered as 1 and this has to be considered as 2. So what I am considering here is alphabetical order. Ethoxy comes first, and now list the same alphabetically. So it's 1 ethoxy, 2 nitro, 1 ethoxy, 2 nitro, and the parent. What is the parent on which the 2 groups were present? That's cyclohexane. Okay, so it's 1 ethoxy, 2 nitro, cyclohexane. One last cyclic compound example and we will wind up with this topic of nomenclature. This is another very important example. There are 2 methyl groups attached here and there is a ethoxy group attached here. Now, which one should be given higher preference? It's a very important example. Remember this rule. When you are talking about cyclic compounds, a more substituted carbon gets higher preference. So this is 1 and this is 2. And so the name is 2 ethoxy 1, 1 dimethyl cyclohexane. Okay, 2 ethoxy 1, 1 dimethyl cyclohexane. The rule to be remembered here is that more substituted carbon gets a higher preference. So I've started numbering from this and not the carbon containing the ethoxy group.